Hello, I am Sajan Acharya, and for my master's project in integrated water resource management at Köln, I looked how two wastewater treatment plants in Bonn are performing today, what's planned for their future, and how AI can integrate the future of sewage plants. Bonn actually run four wastewater treatment plants: Directive, Bad Godesberg, Beuel, and Directive. Each one treats wastewater from their own part of the city and together handling around 0.5 million population equivalents, and currently they are operating at about 490,000 population equivalent, so the system is running close to its full capacity. Even though the four plants in the water independently are treated, they are all connected through a sludge management technology. Every bit of leftover sludge from all four plants end up at the central facility Zeilerweg, where it's incinerated and processed further for the phosphorus recovery. Bad Godesberg treatment plant, which sits on the left side of the River Rhine, has been operating since 1976 and is now running close to its limit utilization, which sits around 98.4% by 22, in which it served 106,000 people against a design capacity of 110,000 by 2022. Now it has been upgraded up to 121,000, which increases the utilization capacity. The strength shows up clearly in the flow numbers. On a dry day, the plant processes about 14,100 cubic meters of water, but during the rain time that jumps to 65,000 since Bonn is operating on the combined sewer system. Over a full year, that totals 8.5 million cubic meters, and keeping the plant running cost the city around 495,000 euro per year in electricity, which is partially offset by the installed photovoltaics. On the treatment side, the plant uses standard multi-stage process: mechanical separation, biological degradation, and chemical dosing. It relies on over 500 tons of iron 2 chloride each year to remove phosphorus, along with chalk and hydrated lime for stabilization. The process also produces around 1534 tons of sludge annually, which is piped through a 7-kilometer tunnel to central Zeilerweg for incineration. Looking ahead, several upgrades are already planned: a UV filtration system for internal plant use, feasibility studies into adding a fourth treatment stage for micropollutants, and a shift of sludge disposal to Köln by 2029 for phosphorus recovery. The city has also allocated up until €1 million a year for more efficient aeration blowers, plus a dedicated €1.2 million in 2027 to modernize the plant sensor and monitoring system, since it lies on the middle of the Rhine-Oy Park. Moving on to the right side, the Beuel has been in operation since 1958 and is smaller than Bad Godesberg, designed for 80,000 people, currently running at around 93% utilization. It handles about 5 million cubic meters of water every year and at a cost of roughly 387,000 euro in electricity. Where Bad Godesberg uses iron chloride, Beuel relies on sodium aluminate to remove pollutants, and it exports about 1,374 tons of sludge a year to central Zeilerweg facility for incineration. What sets Beuel apart is its location. Located on the right side of the River Rhine, that makes the zone flood prone, and flood protection is a central concern. Current projects focus on the reinforcing of the inlet structures and flood pumps to keep the biological tanks protected, and when the river rises, the city is also evaluating whether to route some of the Beuel's flow to a larger regional plant, alongside plans to modernize pumps, rehabilitate tanks, and upgrade automation systems. As both plants are running close to the full capacity, which raises the question, what can actually improve that picture? One clear answer is the artificial intelligence. Flow-aware pump control system could cut energy use by 25 to 30%. Neural network models adapted to the biological treatment stage could reduce aeration energy by another 20 to 30%, which cut emission by up to 40%, and forecast sludge output nearly 2 days in advance. Further downstream, machine learning could adjust chemical dosing in near time and predict membrane fouling hours before it happens. And for the micropollutants like PFH and the pharmaceuticals, AI-powered biosensors could detect them as they pass through, while smart dosing systems optimize ozone treatment to meet the EU discharge standards before the water reaches to the Rhine. These aren't distant possibilities; they are realistic and next step for all of the plants of the Bonn. To sum up, Bad Godesberg and Beuel are two plants of different ages, different challenges, both operating close to their limits under growing demand and climate pressure. Bonn has clear investment plan through the 2029 AVK concept, and there's a real potential to the use of AI to make both plants more efficient, more resilient, with fourth stage approaching faster than ever. I'm open for any questions. Thank you for your time.